I have a question for you. What if we can cool buildings with just a solid state without the use of the traditional cooling system that use refrigerants and compressors and heavy equipment? What if we can just cool a building with the use of just a thermoelectric cooler? This is a very small solid state tool that was developed to be able to cool buildings with just the pass of electricity in. A team at Florida Tech is developing this project that we designed in order to cool buildings through thermoelectric systems. We have our radiative cooling system that is combined with the convective cooling system, and it's able to bring the temperature of the building down to the desirable temperature. This system is highly controllable, and as we can see here on the screen, we can be able to control the temperature of the chamber just from a click on the computer. So we can set the temperature at 19, 20, or even 21 degrees if we want. And the thermoelectric system that is up on the ceiling tile will cool down to that desired temperature depending on how much power this controller gives the system. And this can be done on both the convective cooler, which is outside unit, and the radiative cooler, which is the inside unit that is basically sitting on the ceiling tile.
So when you're creating a product, a big question to ask is why? Why are we making this? So in our current system of the world, energy is obviously a big problem. We're starting to run out of renewable and safe and clean energy sources. Currently, the HVAC systems, they use a refrigerant cycle, which this refrigerant is a chemical that's pretty harmful for the environment. So what we try to design here is a system that does not use a refrigerant cycle. As stated previously, we are going to be using thermoelectric modules, which they have a lot of benefits over the refrigerant cycle. One of them is their steady state. There's no moving parts. It's simply electrical current passing through a semiconductor, and there's nothing to move. The system can be completely modular. You can have one system be on in a certain part of a building and another be completely off and not using any energy. Another benefit, as previously stated, is there's no use of refrigerant. So this process is very safe for the environment, and there's no harmful chemicals being dumped after the fact. Some benefits of radiative cooling are that the system has no airflow. Essentially, this plate becomes extremely cold, and anyone in the room, the heat from their body will radiate towards the cold plate. So that, as stated before, has no moving air, and also there can be a completely modular system. So in a building, you could have this ceiling tile across several square meters of the ceiling, and you could have, if there's people underneath of this section, then only that tile could be operated. But if people move to another section, then that tile could operate, and that would save a lot of energy because only the tile where people are is operating.
This is the second part of our project. It's the convective cooler, and it just runs on a simple system that is designed to accommodate thermoelectric modules sitting on top of a heatsink. The heatsink cools the incoming air and humidifies it, and that incoming air is also dehumidified, which means the water that is in the air is just removed, and that's why you see that bucket right there. It just flows through that bucket, and the air is then pushed into the mixing chamber, which basically mixes the return air that is going to be coming back from the chamber, and it's also cooled again. And as it is cooled, it is again pushed into the chamber through this tunnel, and the air that is in the chamber is humidified and cooled to the desired temperature. This controller right here basically is able to control the temperature of the air that is going to be pushed into the chamber. And there is 9 thermoelectric modules right here that are being used, and they are also cooled so that it can allow for efficiency of those thermoelectric modules. Together with the two systems, the radiative system that is inside, basically with the ceiling tile sitting on the top, and this convective cooler that is just like a ventilation system, they are able to address both the sensible load and the latent load of the system, which enables a better environment within the building. I am Benjamin. I am the project manager for our team of students from Florida Tech developing this system. I would like to thank you.
And I'm Steven, and on behalf of us and all of our team members, we would like to thank you for watching, and we hope that our project can be the catalyst to a future of cleaner and more energy efficient systems in the HVAC sector.